Now that we have reviewed some properties of the position time and the velocity time graph, let's go to graphical analysis. Okay, so we will start with a practice. So let's have, for example, these three curves here. Let's say, for instance, we have a position time graph concerning an object at rest, an object moving with constant velocity, and an object moving with constant acceleration. So what can you say about the velocity at each particular case? So for example, let's say we have an object at rest. What can we say about the velocity of that object? Ano masasabi natin? Since the object is not moving, what can we say about its velocity? Because when an object is at rest, it's not moving by definition. Diba? Therefore, if it's at rest, what can we say about its velocity? Dapat, ano lang? Okay, there's a chat here. Yes. So someone answered 0 dapat. Yes. Therefore, the answer should be 0. In that case, dapat yung line mo, nasaan ngayon yung magiging curve mo for the VT graph? The VT graph should be lying where? In what position or in what part? Dapat, so it starts from the origin, pero since this is a line, therefore it's at rest at the given time, therefore it should be a straight line, a straight horizontal line in the t-axis. Something that looks like this. Tama? Nakuha? Nakuha to? Questions? Nakuha? Nakuha naman. Okay. What about an object moving with constant velocity? What can we say about the VT graph of that? Remember, it's moving now with constant velocity. Therefore, what can we say about its velocity? Velocity, therefore, is constant. Paano mo ngayon i-graph ang isang constant na function? How would you graph a constant function? It's just
a horizontal line, sir.
It's a horizontal line. Pero saan? Nasa positive axis ba ng V o nasa negative axis ng V?
Positive, sir.
Yes, correct. It should be at the positive because from the diagram, the slope of the position time graph is constant and positive. Therefore, we expect that the value of the velocity should be positive, but it's constant. Hence, ganito dapat yung curve niya. Okay? Questions? Questions? May tanong? May tanong ba rito? Are there any questions here? May tanong? Wala? Okay, sige. Let's go. What about an object moving with constant acceleration? What can we say about its velocity? Since there is now acceleration, we expect that the velocity changes. Therefore, but as you see here, pansinin mo, we will assume that it is a parabola. Mukhang parabola, kahit di siya mukhang parabola, kahit mukha siyang quarter circle, pero sige. Okay, let's say this is a parabola. And what can we say about the velocity time graph of that particle? So in that case, you have, from a parabola, we go to a line. But what's the slope of that line? As we see here, if we check the slope at each point, or we get the velocity at each point, instantaneous velocity, lumalaki yung slope. Pwede mong isipin kasing ganito yan. So parang meron kang dito, 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 ganyan, lumalaki. And you see, the slope increases as time increases. Therefore, we expect that if this is a parabola, this should be a straight line going where? Going where? Pataas, pababa, pagilid, saan? Saan dapat?
Pataas, sir.
Yes, exactly. So dapat pataas siya. So parang ganyan. Okay, clear ba tayo rito? Questions? May tanong ba tayo rito?
None, sir.
None. Okay, sige. Now, so I hope this is clear at this part, no? So yan. So now, remember our discussion of deceleration yesterday. When dun sa mga nakapanood, that's the last part of the discussion. So nasa part 6 of 6 yan. Okay, so we have sign conventions for both velocity and acceleration. The important thing here is that if both velocity and acceleration are in the same direction, then the object is speeding up, regardless kung nasaan siya nakapoint. It's speeding up maybe in the positive axis or in the negative axis. But the point here is that the object is speeding up if the signs of both the acceleration and the velocity are the same. Otherwise, the object slows down and you have deceleration happening. So nagde-decelerate yung particle. So deceleration. You have deceleration. Okay, so yan. So for example, if the velocity if both velocity and acceleration are positive, we will assume in our coordinate system that, that a particle moving to the right is positive, points to the positive direction, and the particle moving to the left points to the negative direction. So in that case, if both the velocity and the acceleration are moving to the right, then they are speeding up. Okay, sige. And then if both the velocity and the acceleration are moving to the left, then they speed up, pero they're both moving to the left if they have the same negative signs. So now, if the velocity and the acceleration are in the opposite directions, such that the velocity is positive, but the acceleration is negative, then we say that the particle still moves to the right, but it slows down. Okay, the particle still moves to the right, but it slows down. On the other hand, if the velocity is negative, but the acceleration is positive, then the particle moves to the left, but it slows down. Okay? Now, this is what I want to emphasize. The displacement and the velocity vectors are parallel. But it is possible, pumiyok na ako, it is possible that the acceleration and the velocity are not parallel. Okay? That will be important, especially when you go to 2D and 3D. Ang displacement at velocity vectors, parallel yan. Bakit? Because remember your definition of velocity? This is just delta, di ba delta x, delta t yan? And since delta t is never negative, weird yun pag nag-negative ang time interval mo, then we say that you can think of it as v if just stretched or squeezed by some 1 over delta t. So para kang in a way, para kang nag-scalar multiplication ng 1 over delta t sa delta x. Therefore, your x and v should be, or your displacement and velocity should be in the same direction. Laging parallel yan. Okay? Clear ba yun? Clear yun? Whereas, acceleration and velocity need not to be parallel. So huwag kayong magugulat kung hindi parallel yung acceleration and velocity because they're not always parallel. In general, they're not parallel. Okay? Questions? May tanong ba rito? May tanong dito? May tanong? Are there any questions here? So, wala naman? Okay? Sige. Now, so, let's answer another conceptual question. Given the following xt graphs, answer the following. Which pertains to an object with a constant speed? Alin dito yung constant speed? Actually, pinakita ko na kanina. Alin dyan? Please chat your answer. Use the chat to your answer. Is it A, B, C, or D? Pili na kayo. Yan. So there are answers here. So most of you got? Yes, correct. Your answers are correct. The answer is D. Tama. Now second, which pertains to an object that reverses direction? Paano pag bumalik yung object ko? Paano pag bumalik yung object ko? So what can we say? Okay, most of you answered A. Why is it A? Bakit A? Kasi yung napansin mo rito, so, una, pataas ng pataas or palayo ng palayo yung particle. If palayo ng palayo yung particle, palaki ng palaki yung displacement niya with respect to the origin. But however, after some time, bigla siyang huminto at bumalik dito. Ganun yung ginawa niya. Hence, the answer is, in this case, ni-reveal ko na yung sa number 3. Letter D yung sagot sa number 3. Okay, for an object that reverses direction, the answer is A. For an object that starts slowly and then speeds up, the answer is D. Why? Why is it that way? Bakit ganon? Bakit ganon yung sagot? No?
So, umpisa hindi po lumalayo yung position.
Kasi you can think of it this way. What is the slope at the initial position? So at this point, pwede ka maghanap ng slope of the tangent line dyan. Dito, di ba? Medyo hindi masyadong steep yung slope mo. So dito, medyo hindi masyadong steep yung slope mo. But once you get here, lumalaki yung slope, parang ganyan, and gumaganyan. So in that case, since the velocity increases, then it speeds up after some time. And since we will see that in next time, later in curvature, lumalaki kasi yung velocity, therefore you expect that it is accelerating in the same direction as the velocity, and therefore the particle speeds up. Okay? May tanong ba rito sa item na to? May tanong ba? Are there any questions in this particular item? None. Okay, sige. So, Okay. So from the velocity and from the position time graph, usually kasi kung una natin kailangan i-analyze ay position time graph. But later we will also analyze a velocity time graph. But for our example, before we go to a more general case, let's go to first to the position time graph kasi mas madaling i-interpret yon. Now, here's the thing. So for a position time graph, the slope of each point, alam na natin to, the slope represent, for example here, the slopes of these points represent the velocity, or more specifically, the instantaneous velocity of the particle. Whereas the curvature, kung kurba pababa o pataas ba yan, it represents the acceleration of the particle. Okay? Questions? May tanong ba rito? Are there any questions? May tanong ba rito? Wala? Walang tanong? Okay. Sige.